Hello, good afternoon. I hope you enjoyed that quiz and I hope you guys did well. I'll try to grade and give you your grades on Monday, but that's not a promise. So, the video I want you to watch this evening is, or maybe this weekend, is double angle, half angle, and reduction formulas. We've looked at how to simplify and solve trig equations with identities. We've looked at how to use the sum and different formulas. Now let's look at the double angle, half angle, and reduction formulas. Now, these are formulas that I want you to add to your note card. This is a bunch of them. The sine 2 theta. When we said double angle, it simply means that the angle in this situation is being doubled. So we've been used to sine theta, cosine theta, but in all of these formulas you have cosine 2 theta, sine 2 theta, tan 2 theta. And I hope you notice that cosine has 3 different expressions for its double angle, and that comes from this idea because cosine 2 theta is cosine squared theta minus sine squared theta. Because of that, we can express this expression in terms of sine alone or in terms of cosine alone. So write down these formulas on your note card and let's see how we can start to use them. So this example wants us to use the angle sum formula to prove that sine 2 theta is equal to 2 sine theta cosine theta. And by the way, you can use the angle sum formula for each of these ones to prove these formulas. This is something you can do for practice and for your own benefit. You can use the formula of sine theta plus theta, right? Because we've been used to sine alpha plus beta is equal to something. You guys know the expression. But if these angles are the same, if it is theta plus theta, then what does that become? You can work this out on your own so that it gives you a better appreciation of these formulas. You can do the same thing for cosine of theta plus theta and then see what this formula gives you. So this is the origin of the double angle formulas, but I don't want you to spend too much time, or the emphasis of the class is not that you know how to derive them, but rather that you know how to use them. But like I said, there's value in you knowing how they come about. So if you have the time, I advise that you go ahead and break this down and see how this comes to this. So back to this example, sine 2 theta is the same as sine of theta plus theta. And we know from the sum formula for sine, if we have sine alpha plus beta, it's the same as sine alpha cosine beta plus cos alpha sine beta. So if I apply that to this idea here, beta and alpha are the same angles, so this will just be sine theta cosine theta plus cosine theta sine theta. Well, sine theta cosine theta and cosine theta sine theta are the same exact thing, just written in opposite order. So let me write them in the same order. Because it's multiplication, it's what's the word? Multiplication is commutative, yeah? So I can write whatever. I can write 1 times 2, it's the same as 2 times 1. So I see that I have the same thing and I have it twice. So I can just say I have 2 of the same thing. So 2 sine theta cosine theta. And this is where the double angle formula for sine comes from, right? This is the double angle formula for sine, and you can use this approach to prove all of the other formulas. We also have something called the half angle formula. Half angle is simply because the angle is halved, right? The angle is halved. So that's why you have the half angle formula. If you're interested in seeing how these come about, I'm going to post the video that I did last year for this same class. In that video, I went in detail and it was a long video. So if you're interested in seeing how this comes about, I'll add that to the post. But these are the half angle formulas, and I just want us to just use them. I know you can see there's a plus or minus sign in front of each of these formulas. Well, that plus or minus sign depends on the quadrant in which the angle is. You remember that in these quadrants, all sine, tan, and cosine. So if the angle is in any of these quadrants and that ratio is positive or negative in that quadrant, then this formula will have that corresponding positive or negative. What is the exact value of cosine 22.5? Well, I hope you can see that cosine 22.5 is the same, 22.5 is 0.5 is half of 45, right? So I'm going to try to find this half angle formula for cosine 45. Now I know my theta is 45, so this is going to be equal to a positive because 45 is in the first quadrant and cosine is positive in the first quadrant. square root of 1 plus cosine 45 divided by 2. So this will be 1 plus cosine of 45 is root 2 over 2. I'm dividing all of it by 2 and taking square root. So that simplifies to 2 plus root 2 divided by 2 divided by another 2 under square root. So that becomes 2 plus root 2 divided by 4. I hope we can all see that. And then that at the end of the day becomes 2 plus root 2 over 4, but the numerator is under a square root. No, sorry, over 2. Not over 4. Over 2. So that's my exact value of cosine 22.5 without using a calculator. Alright, let's look at another one. We have something called reduction formulas. And again, in the video that I did last year, I went into detail about how to prove these. But if you're interested, you can go and check those out. But please write them on your note card as well. And just a quick hint is that those reduction formulas specifically come from this expression of cosine 2 theta. So for the sine, I made sine the subject. For the cosine, you just make cosine the subject. So those reduction formulas, which are these ones, and for the tan, you go to the tan function. I mean, the double formula for sine and cosine, and then make sine squared divided by cosine squared to give you tan squared. What I'm trying to say is when you divide this one by this one, you get this one, right? Because tan is sine over cos. However, I know you're not very interested in how they come about, so let's stick to using them. These are the formulas. Write them down on your note card, and then let's try to use them. Write the expression with an exponent no higher than 1. So they want the highest exponent to be 1. That means I need to reduce this power, which is a power of 4, and make it a power of 1. How do we do that? I see that sine squared theta can be reduced to cosine 2 theta minus, 1 minus cosine 2 theta all divided by 2. So here the highest power is 1, but here the highest power was 2. So that's the idea I'm going to use. Sine to the power 4 of 8x is the same thing as sine squared of 8x to the power 2, right? Now this sine squared, I can express it using this expression. Sine squared is 1 minus cosine twice of the angle divided by 2. So I'm going to substitute for this. I know that sine, let me write it here, sine squared theta is equal to 1 minus cosine twice the angle all divided by 2. So this thing in my brackets is going to become 1 minus cosine twice of the angle. So twice of 8x is, twice of 8x. We just write it there. Everything divided by 2, but this is still squared. So if I'm to simplify, I have 1 minus, cosine 16x all divided by 2. However, it's still squared, and they want my highest power to be 1. So I'm going to square this expression. If I square this expression, I will have 1 minus 2 cosine 16x plus cosine squared 16x, everything divided by 4. That's what I get when I square the whole thing. So this has a highest power of 1, this has a highest power of 1, but this cosine squared term does not have a highest power of 1. So I'm going to go back to my reduction formulas and ask myself, if I have cosine squared theta, what does it become? It becomes 1, cosine squared theta becomes 1 plus cosine 2 theta divided by 2. So I'm going to replace this cosine squared here with this idea, right? So my final answer is going to be 1 minus 2 cosine 16x plus, instead of cosine squared, it will become 1 plus cosine twice the angle all divided by 2. But remember, this whole thing is over 4. So I made that substitution, 1 plus cosine twice of the angle divided by 2. I'm just going to simplify it and write the final answer. So I'm going to skip a step, but these two will multiply everything here, and then finally we'll multiply the 4. So this will become 2 minus 4 cosine 16x plus 1 plus cosine 32x, everything over 8. And I can add the 2 and the 1, and my final answer will be 3 minus 4 cosine 16x plus cosine 32x. So that's how you will reduce these expressions, and I've done that reduction. Let's look at another example. Find the exact value of sine 2x, cosine 2x, and tan 2x without solving for x if tan x is equal to 8 and x is in the fourth quadrant. Okay, x is in the fourth quadrant, that's important. So that means the only thing that's positive is cosine, right? The only thing that's positive is cosine, everything else is negative. So they want me to find sine 2x. How am I going to do that? I know that sine 2x is equal to 2 sine x cosine x, right? But I've been told that tan x is equal to negative 8 over 1, and that angle is in the fourth quadrant. So let me draw this triangle here. If it's in this fourth quadrant, this is like your 0 or 2 pi. This is your angle x. Tan is opposite over adjacent, so the opposite is 8, the adjacent is 1, and I can use that idea to find the hypotenuse. I hope you guys can see that the hypotenuse will be the square root of 65, right? 1 squared plus 64 square root. So from this triangle, the cosine of x will be equal to 1 over square root 65, and the sine of x is equal to 8 over the square root of 65. So the sine is going to be negative because it's in the fourth quadrant, the cosine is positive because it's in the fourth quadrant, and the tan is still negative. So I'll just come and substitute those values in this expression. That sine 2x is supposed to be 2 sine x cosine x according to the double angle formula, and I'm going to substitute 2 times sine x is negative 8 over 65 square root, times cosine x, which is 1 over 65 square root, and my final answer will be negative 16 divided by 65, because square root 65, square root 65, the square root cancels out, and I just end up with 65. Alright, now let's try to get the cosine 2x. Cosine 2x, according to this formula, I can either use this one, I can either use this one, or that one, right? I'm going to pick the easiest one to use. I'm going to pick the cosine x, right? Cosine x. Cosine 2 theta in terms of cosine is just 2 cosine squared theta minus 1. Like I said, you can pick any one of these three because you have the sine, you have the cosine, so you can pick any one of these three. So I'm going to use the third one, 2 cosine squared x minus 1. So this is going to be 2 cosine is 1 over 65. So that's 1 over 65 squared minus 1. And whichever one you use, you have to get the same answer. You will get the same answer. So this is going to be 2 over, or this was square root 65, sorry. But when you square the square root disappears, so you have 2 over 65 minus 1. What does that give us? 2 over 65 minus 1. That's as if you're subtracting 2 over 65 minus 65 over 65, which gives you 63 negative over 65. So, and I want you to check my answers by hopefully using a different one. You'll see that you'll get the same exact answer. Finally, they want us to get tan 2x. Tan 2x, according to this, is 2 tan x divided by 1 minus tan squared. It's just going to be 2 tan x over 1 minus tan squared x. So that's just 2 times, because tan x is 8, right? So that's just 2 times negative 8, sorry, divided by 1 minus negative 8 squared. So that gives you 2 times negative 8 is negative 16, divided by 1 minus 64, which is negative 65. So tan 2x, what am I saying to tan x? Tan 2x is 16 over 65. So that's how you do questions like this. Alright, find the half angles, the sine theta over 2, the cosine theta over 2, and the tan theta over 2. Well, we have from this expression, if this is 5 and this is 12 by Pythagoras, I think you'll find that that hypotenuse is 13. And the sine of theta is 5 over 13. The cosine of theta is 12 over 13. And the tan of theta is 5 over 12. So I'm just going to substitute those values into this expression. The sine theta over 2 will be equal to, it's positive because this angle is in the first quadrant. That's what I'm going to assume, because nothing is said, so I'm going to assume it's in the first quadrant. So sine theta over 2 will be 1 minus cosine theta, which is 12 over 13. Everything divided by 2, everything under square root. So you guys go ahead and simplify this. I trust that you can simplify this. So this will be 13 minus 12, which is 1 over 26, I think, square root. Check my work. Cosine theta over 2 will be equal to 1 plus cos theta over 2. So that's 1 plus 12 over 13 divided by 2 square root. That's 13 plus 12 is 25 divided by 26. Again, check my work. And then tan theta over 2 is equal to this interesting expression, either the square root of this, or 1 minus cos over sine, or sine over 1 plus cos. So you can use any of these three. I'm going to use the second one. It's 1 minus cosine is 12 over 13 over sine, and sine is 5 over 13. So when we simplify this, we have 13 minus 12 in the numerator, which is 1 divided by 13, and in the denominator we have 5 over 13. So when you do the KFC, if you flip 13 over 5, we end up seeing that the half angle for tan is just equal to 1 over 5. Yeah, 1 over 5. So yeah. Next one, oh, sorry. Yeah, Pythagoras gives you 13, and then you start the substitutions, and you solve the problem. Simplify, do not evaluate. If you can, you know, the biggest idea or the biggest practice or trick in this unit is going to be recognizing the ideas, recognizing the patterns, or recognizing and making connections, right? That's going to be the biggest thing. And I told you, a lot of the time it will feel like your brain is doing push-ups, which is good for your brain. So as soon as you look at this, right, let's take the 28 out and call it theta, sine squared theta. Go back to your note card and ask yourself, which formula is this, right? Which formula looks like this? And if I go back to my note card, which is over here, the formula that looks like that is one of the expressions of the cosine 2 theta, right? One of these expressions in cosine 2 theta looks like this. So with that in mind, that makes my work very easy, because I know that cosine 2 theta is equal to this, right? Then I know that this expansion here will just become, if this whole thing is cosine 2 theta, then I just need to multiply the angle by 2, and it's simplified. So this whole thing will become cosine 2 times 28, and 2 times 28 is it 56? Yeah. So I have simplified this expression. It becomes easier when you can make these connections faster, and you know, the homework will help you to practice that over and over and over again. So yeah, that's the video. We'll look at this homework in class on Monday. Have a great weekend. Bye.